Now, let's look at question 10. Please tell if functions f of x equals x cubed and f of x equals cube root of x and f of x equals 1 over x cubed are even, odd, or neither. Here we want to say is that for question 10, all these three functions are odd. The answer, that's the answer. Why? Algebraically, for odd function, if we have a f of negative x equals negative f of x, then we are done. Now, let's work on f of x. If f of x equals x cubed, then we shall have a negative plug in, so we have a negative f of x cubed. So if here is x, here is x, when you plug in negative, you should also have a here, negative. And then we know there's negative x times negative x times negative x 3 times. This is negative, and then cube root. Because this one, x cubed, is just f of x, so you then have a negative f of x. Algebraically, you can have is when you plug in negative inside f of x, and then this negative sign gets out, so we will say this function is an odd function. So no problem for this. For f of x equals x cubed. Similarly, one can prove let's say instead of f, similarly, one can prove f of x equals, for this one, cube root of x and f of x equals 1 over x cubed are odd functions. Okay? So that's algebraically. And the geometrically, what's the meaning for that? Geometrically is like this. Let's consider the picture. Here we have a x cubed. This picture is the one right here. And then this is the picture for x to the 1/3, and this is the picture. And for x, f of x equals x cubed is the red one. And then here is for f of x equals 1/x cubed. We may consider the graph for 1/x cubed. You see here, when you input h of 2, replace x with 2, you have a 0.125. We know h of x is 1/x cubed. When we plug in 2 here, so we get 1/2 cubed. And then there's 1/8, that's 0.125. If you plug in -2, you have a 1/2 cubed, and that's -1/8, and that's -0.125. And we know 0.125 is this one, and which is this one. So we know that will be h of 2, but there was a negative, so you have a negative here. This basically says is that, let me get my mouse out. I want to point out. This basically says that h of -2 equals negative h of 2. Okay? So here, again, x is 2. You have a 0.125. So that is the point here. Let me zoom in. Zoom in right here. So you have a x is 2, you have a 0.125. And then when x is -2, you have a -1.25. That's the one right here. And then when you connect those 2 points, these 2 points, the line passes through this origin. That means when you rotate this line 180 degrees, this point to 0.125 will be here, and this point -2, and then -0.125, this point will go to this place. They exchange. So for the odd function, they have this property. If you have a 2 and positive 0.125, you should have a negative also on the graph. Okay? So that's why we say every point on this curve has a corresponding point somewhere here. So we say this graph for the one here, this one, is symmetric with respect to the origin, because, again, when they connect those two, the line will pass through the origin. will pass through the origin. So then we say the graph is symmetric with respect to the origin. You added one for this one. You may work on this one the same. You can get out the picture. This is the one for cube root. Okay, you see there is a point here, then there is a point here. Okay, when you connect these 2 points, the graph goes through the origin. So when you rotate this curve 180 degrees, this point goes to here and this point goes to here. So the graph of this one is symmetric for the cube root with respect to the origin. Then that's the odd graph. Similarly for this one, f of x equals x cubed. So again, 1, 2, 3, those 3 functions, they are odd function. And algebraically, this is the property, and the geometrically means that positive, positive, then you have a negative, negative. The signs are opposite. Okay, so here again, the algebraic expression has this property, and here is the concrete example. F h of negative 2 is negative h of 2. So algebraically, we have this. Geometrically, they are symmetric with respect to the origin. Those are the important properties for the odd function. All right? Okay, I'll see you next time.